So welcome back, and we're carrying straight on. If you haven't tried these questions, have a look at them. All right, so this first one says, is each of these triangles possible? All right, is it possible to draw a triangle like this? And let's have a look at that idea that the shortest side, all right, there's the shortest side, and the smallest angle, they have to be opposite one another. And so this triangle is not possible. No, can't draw this triangle. All right, and the reason it's impossible is that the shortest side, notice the longest side is opposite the longest angle, all right, but the shortest side is not opposite the shortest angle. Not opposite the smallest angle. Okay, is this one possible? And remember the idea that this is definitely not possible. You can't make a triangle like this because these two sides don't manage to match that side. They're actually shorter. So this one's not possible also. All right, and the reason is that the longest side is bigger than the sum of the other two sides. Right, this stuff is a little bit sort of extra, okay, which is not normally taught, but I think it's important. This is a nice question. It says, see how many different triangles you can make with sides which are integers and have a perimeter, total side length of 12. Okay, all right, so we're going to just think about that briefly and then we'll write them down. Okay, in fact, there are only three. We can draw one that's going to look something like this, where 2, 5, and 5. We can draw one that's going to look something like this, 4, 4, and 4. And then lastly, we can draw one that's going to look something like this, 3, 4, and 5. Those are the only three that are possible. Okay, right, you can't have a side of 6 because the other two sides would have to be 6, and they need to be longer than the longest side. Okay, right, now we're going to talk a little bit about classifying things, right? And you're probably wondering what's going on here. Okay, if we had all these shapes, okay, all these objects, not shapes, a table, a dog, a snake, a tree, a computer, a cactus, a fish, a pencil, and a turtle. So what's happened here is that they've been classified. Can you see what we've grouped them into two different groups? Can anybody tell me what basis, what have we done here? How have we decided that these things should go over here and these things should not? Okay, all right. Well, the rule that I've used here is that all these things have 4 legs. Okay, a table has 4 legs, a tortoise has 4 legs, and a dog has 4 legs. These things don't have 4 legs. Right, let's think about a different classification. Okay, all right, over here, where would a coffee cup go? If we had a coffee cup, where would we put it? Yeah, a coffee cup would go over here. Okay, I can't draw, which is why I'm a maths teacher. All right, then what about this one? Okay, what's happened here? Well, now we've got a different way of classifying them. This time we've classified them into non-living things, the computer, the table, and the pencil. And on the right-hand side, we've got living things. And in the living things, we've actually classified them further into plants and animals. All right, and in the animals, we've got two that are actually different type of animals. They're special type. They're called a reptile. Okay, all right. Where would an eagle go? Where would we put an eagle if we now said, right, we've got it? Okay, it's definitely a living thing, so it wouldn't go in here. It's not a plant. It's an animal. An eagle would go in here. Okay, and I'm just going to draw a picture of an eagle flying. All right, that's as good as my art gets. There's my eagle over here. All right. And it says, what about a branch from a tree? Well, if the branch has been cut off the tree, then I would argue maybe it's a non-living thing now. All right. Okay. Right. Now, what we're going to do is we're going to try and classify triangles. Okay. And so the first type is what we call a scalene triangle. It's got nothing special about it. It's got no equal sides and no equal angles. The next one is what's called an isosceles triangle. It's got two sides equal. And I want you to remember another thing that we said. Remember we said the biggest side's got to be opposite the biggest angle. Well, if these two sides are equal, then these angles that are opposite them must be equal. So an isosceles triangle has two equal sides and two equal angles. And the sides opposite the equal angles are equal, and the angles opposite the equal sides are equal. The last type that we're going to look at is called an equilateral. Equal, lateral means sided, equal sided. So all three sides are equal. Now remember, big idea number 2 is that the biggest side's got to be opposite the biggest angle. If these sides are equal, then the angles opposite them must be equal. And there's only 3 of them. They add up to 180 degrees, so they must each be 60 degrees. So equilateral triangles always have 60 degrees. All right, we also get a right angled triangle, and that's obvious. It's just a triangle with a 90-degree angle. We get an acute angled triangle, and that's one where all the angles are less than 90 degrees. And then we get an obtuse angled triangle, and that's one where we've got an angle bigger than 180 degrees, bigger than 90 degrees. Okay, we can't have more than one angle bigger than 90 degrees. We can't have more than one obtuse angle, all right, because remember the angles of a triangle add up to 180 degrees. So if one of them is more than 90, the others will have to be less than 90. Okay, just think about that. We can't have like a 93-degree angle and another angle bigger than 90 degrees, all right, because now we've already got more than 180 degrees and we still have a third angle. Okay, so this is going to be impossible. All right, the only way that would be possible is if we had a negative angle. We can't have a negative angle. Okay, right, now on the next page, we've got a whole lot of triangles. And what we want you to do, and they are, you've got the table next door, we want you to just tick which, for triangle number 1, let's do triangle number 1 together. So triangle number 1 is this one over here. It's got all 3 sides equal and all 3 angles equal. It is it's an equilateral triangle. Okay, I see our table is actually missing the opportunity to say equilateral. All right, I'm actually just going to, it does have 2 sides equal. It's actually a special type of isosceles triangle. I'm actually going to tick there and I'm going to write equilateral. Okay, it is acute angled as well. So we would tick those 2. Right, we want you to pause the video and try and complete this table. Okay, I see that there actually should be a column, and I hope you've got the column in your workbook. I think you have, for equilateral triangles. So number 1 was acute angled and equilateral. Number 2. Right, number 2 is isosceles and acute angled. Number 3 is also isosceles and acute angled. Number 4 is scalene and it's obtuse angled. Number 5 is scalene and right angled. Number 6 is just acute angled. All right, sorry, it's acute angled and it's equilateral. Number 7 is isosceles and acute angled. Number 8 is scalene and obtuse angled. Number 9 is scalene and obtuse angled as well. Number 10 is acute angled equilateral. Number 11, all right, is isosceles and obtuse angled. Number 12 is scalene and right angled. Number 13, also scalene and right angled. Number 14 is another equilateral triangle, which makes it acute angled as well. And number 15 is isosceles, obtuse angled. Number 16 is acute angled equilateral. And number 17, lastly, is scalene and right angled. Okay, so just make sure you've got all of those. Right, now the next thing we're going to ask you to do, we're going to see if you can make two different triangles by joining dots in these circles. Okay, and each of them will have angles which are a multiple of 36 degrees. All right, so the first thing we could do is we could join two dots that are next to one another. All right, and once we've done that, then we could join maybe to those two dots. Okay, I just need to redraw that line. It hasn't drawn it nicely for me. There we go, that one and that one. And it says, see if you can estimate the angles. All right, and in fact, the angles are going to be, remember, they're going to be multiples of 36. This looks like it could be 36 degrees, and this one also 36. Now, if those two are 36, then in fact, the next multiple of 36 that might fit in here would be 108 degrees. And we can actually see that that's possible because it adds up to 180 degrees. So that's one possible triangle. There is another possible triangle, all right? And let's see what that one might look like. If we were to join two dots next to each other, and instead of going to one of the dots next door, we go to the one right across on the other side here. So I have to redraw that line right across there and right across there. All right, remember they're going to be multiples of 36. So this looks like it must be 36 degrees. And this here must be two lots of 36, which is 72, and two lots of 6, which is 72, 36 and 72. And notice that, once again, they add up to 180 degrees. Those are the only two triangles that we can fit in there. Now, the next one, we want to see if you can make three different triangles by joining dots. And the triangles must be different. Okay, this time each triangle will have an angle which is a multiple of 30 degrees. Okay, pause the video and try this. It's just an interesting exercise, but it really helps us think about where we could make triangles. Okay, so the first thing we could do is we could just join two dots that are next to each other. All right, and having joined two dots that are next to each other, we could then either go sort of right next door here. Let's do that. Okay, and now we would have to join those two up. All right, so remember we're talking angles that are multiples of 30. This here looks like it's going to be a 30-degree angle and a 30-degree angle. Now 30 and 30 is 60, and this looks like it's going to be 120 degrees. So that's one possible triangle that we could draw. If we join two dots that are next to each other, doesn't matter where they are, all right? Two dots that are next to each other. So for example, there and there. Last time we went to a next door dot. This time we're actually going to go to a dot across on the other side here. All right, so it's going to do that and do that again, like that. Okay, and now obviously we're going to join those two. All right, now this one is a multiple of 30. It looks like it's 30. This one, if it's a multiple of 30, it's either 30, it looks bigger than 30, it must be 60. All right, and this last one looks like it's 90, and it in fact is 90. Do that up to 180 degrees? Yes. What I want you to see is that had we gone across to that dot, we would have got the same triangle. We would have got the same 3 angles. There's one more possibility. Did you manage to find it? Right, remember we started off joining a dot to a dot right next door. If we join a dot to a dot that is 2 away, like that, okay? Now we've got choices. If we go and join here, we're actually going to get the same triangle there. And if we join there, we're going to get a 30, 60, 90. If we join here, right, what I didn't mention to you right up front is that pencil's a really good idea for all these tasks. Okay, now this triangle, if we look at it, these sides all look like they're equal, and these angles are multiples of 30. So in fact, these are 60, 60, 60, and notice here we've got an equilateral triangle, here we had an isosceles triangle, and here we had a right-angled triangle. Okay, right, now we're going to ask you to try, before the next lesson, we're going to ask and see if you can make 7 different triangles. We've given you 7 circles, all right, and we're going to see if you can make 7 different triangles, and each time the angles will be a multiple of 20. Okay, that might take you quite a while. We strongly recommend you use a pencil, okay, and see if you can get all these different triangles. Right, good luck with that, and we look forward to seeing you next time.